Q7265. The fan guard surrounds the propeller and A. Increases aerodynamic efficiency. B. Reduces P factor. C. Protects the parachute suspension lines from damage. The correct answer is C. The fan guard, in the context of weight shift control aircraft, surrounds the propeller, and its primary purpose is to protect the parachute suspension lines from damage. In weight shift control aircraft, the propeller is located behind the pilot and is driven by the engine. The propeller generates a significant amount of airflow, and the fan guard serves as a protective barrier around the propeller to prevent the parachute suspension lines from coming into contact with the spinning propeller blades. The fan guard helps to ensure the safety and integrity of the parachute system by providing a physical barrier between the propeller and the suspension lines. Therefore, the correct statement is the fan guard surrounds the propeller and protects the parachute suspension lines from damage. 7266. Cross ports in the parachute ribs aid in A. Weight reduction of the canopy. B. The pressurization of the neighboring cells. C. Drying of the canopy. The correct answer is B. Cross ports in the parachute ribs aid in the pressurization of the neighboring cells. In weight shift control aircraft, the parachute used for lift and control consists of a canopy with ribs that create individual cells. These cells are responsible for capturing and directing the airflow to generate lift. The cross ports, which are small openings or vents, are strategically placed in the ribs of the parachute canopy. The purpose of these cross ports is to allow air to flow between adjacent cells during flight. As the aircraft moves through the airflow enters the cross ports and pressurizes the neighboring cells. This pressurization helps maintain the shape and integrity of the parachute canopy, optimizing its performance. Therefore, the correct statement is cross ports in the parachute ribs aid in the pressurization of the neighboring cells. 7267. Splicing severed suspension lines. A. Is permissible if using the same size material as the original line. B. Is a very dangerous practice. C. Is an acceptable field repair. The correct answer is B. Splicing severed suspension lines is a very dangerous practice. When it comes to the suspension lines of a parachute or any other critical component of an aircraft, it is essential to prioritize safety and adhere to proper maintenance and repair procedures. Splicing severed suspension lines is generally considered unsafe and is not an acceptable practice. Suspension lines play a crucial role in the structural integrity and performance of a parachute. They are responsible for supporting the load and distributing the forces evenly across the canopy. Any damage or weakening of the suspension lines can compromise the parachute's functionality and, ultimately, the safety of the pilot. Repairing severed suspension lines through splicing introduces a potential weak point in the line, which can lead to catastrophic failure during operation. It is difficult to ensure the same strength, integrity, and proper alignment of the original line through splicing, making it an unreliable and dangerous practice. Instead, when suspension lines are damaged or severed, it is recommended to replace them with new lines that meet the manufacturer's specifications. This ensures that the parachute maintains its original design and performance characteristics, providing a reliable and safe operation. Therefore, the correct statement is splicing severed suspension lines is a very dangerous practice. 7268. Tying a severed suspension line. A. Will change the shape of the wing and is not permissible. B. Is permissible if it is shortened no more than 6 inches. C. Is an acceptable field repair. The correct answer is A. Tying a severed suspension line will change the shape of the wing and is not permissible. When it comes to the suspension lines of a parachute or any other aircraft component, it is important to follow proper maintenance and repair procedures to ensure safety and performance. Tying a severed suspension line is generally not permissible and can lead to undesirable consequences. Suspension lines play a critical role in maintaining the shape and stability of the parachute wing. They are carefully designed and calibrated to distribute the load evenly across the canopy, allowing for controlled flight and descent. Tying a severed suspension line can introduce irregularities and changes in length, tension, and alignment, which can alter the shape of the wing. Changing the shape of the wing by tying a severed suspension line can disrupt the aerodynamic characteristics of the parachute. This can lead to unpredictable flight behavior, reduced control, and compromised safety. Tying a severed line may also affect the overall balance and symmetry of the parachute, further impacting its performance. Instead of attempting to tie a severed suspension line, it is recommended to replace the damaged line with a new one that meets the manufacturer's specifications. This ensures that the parachute maintains its intended shape and flight characteristics, providing a reliable and safe operation. Therefore, the correct statement is, tying a severed suspension line will change the shape of the wing and is not permissible. 7268-1. What gives your powered parachute wing/canopy its airfoil shape? A. The risers, because by decreasing the length of the right riser you will get the precise airfoil shape. B. The suspension lines, as they are precisely measured and fitted to a specific location. C. The air as it enters the cell openings on the leading edge of the airfoil. The correct answer is B. The suspension lines give the powered parachute wing/canopy its airfoil shape. The airfoil shape of a powered parachute wing is primarily determined by the suspension lines. The suspension lines are carefully measured, fitted, and attached to specific locations on the wing to create the desired airfoil shape. The suspension lines provide the structural support and tension necessary to maintain the shape and integrity of the wing during flight. They are attached to the ribs and span-wise seams of the wing, creating a network of tension lines that define the airfoil profile. By adjusting the lengths and tensions of the suspension lines, the shape of the wing can be precisely controlled. The design and positioning of the suspension lines are carefully engineered to achieve optimal aerodynamic performance, stability, and handling characteristics. The air entering the cell openings on the leading edge of the airfoil contributes to the inflation and pressurization of the wing, but it does not directly determine the airfoil shape. The airfoil shape is primarily influenced by the suspension lines and their arrangement on the wing. Therefore, the correct statement is, the suspension lines give the powered parachute wing/canopy its airfoil shape.